With the rise in global atmospheric temperatures, the ice-covered polar region is melting day after day. It is a matter of life and death for many island nations and underdeveloped countries. On the other hand, the countries with military might perceive it as an opportunity to capture and extract 13% of the world's crude oil hidden beneath the Arctic Ocean. Overall, this uncharted territory of the Arctic has more than 90 billion barrels of crude oil and 1/3 of the global natural gas deposits. Globally, about 35 billion barrels of crude oil are used each year. The race has already begun, and Russia, the dominant force in the region, is ahead of the game, capturing the barren territories of the Arctic with its military might. President Vladimir Putin has launched a major Arctic project, Arctic LNG-2, to tap the region's vast treasure of liquefied natural gas, LNG. This ambitious endeavor will not only secure Russia's position as a major energy player, but also cement its status as a global superpower. But Russia is not alone in this quest. The United States, though not a signatory to the United Nations Convention on the Law of the Sea, is working to expand its own claims to the extended continental shelf. Canada, Norway, and Denmark are all jostling for position, each seeking to claim a piece of the Arctic pie. This black gold has always been central to international affairs. From waging wars to racing cars, from budgeting economies to producing electric power, and from firing stoves to changing the climate, hydrocarbons influence the world in a million ways. After all, it is the fuel of our modern world. Although hydrocarbons started forming underneath our Earth millions of years ago, scientists discovered their power to run engines in the late 19th century. Since then, the world has seen a huge transformation. The crude oil made it possible to use large machines, process a lot of products in factories, and travel through the skies. Today, the United States is the world's largest oil producer. According to the EIA, the country produced 12.9 million barrels per day in 2023. It becomes 4.7 billion barrels per year, which is approximately 12% of crude oil globally produced in a year. The first oil well was also drilled in the United States by the Pennsylvania Rock Oil Company in Titusville, Pennsylvania. But how is crude oil extracted? Why is seismic equipment deployed before drilling? How does a drilling rig work, especially when there is no way of directly drilling down to Earth? Let's find out. But first, it's worth noting that crude oil extraction is as difficult as rocket science. Here, we attempted to briefly explain the important crude oil extraction processes for our common audience. Hopefully, you have already subscribed to our channel. Before doing anything, the geology of the site is meticulously studied. For this purpose, seismic trucks are used. A seismic truck features a vibration device. This piston is connected to a hydraulic system that supplies the force needed to make the ground tremble. The vibrations are controlled by an electrohydraulic servo valve, which ensures that the force is precisely regulated to achieve the desired effect. It generates vibrations that send shock waves through the ground. Several seismic trucks are deployed, which thoroughly analyze the oil reserve area. The vibrations are typically in the range of 20 to 150 Hz, which is a frequency that is easily felt by humans but not loud enough to cause harm. The truck can generate forces of up to 90,000 pounds per square inch, which is equivalent to the weight of several elephants. The vibrations are designed to penetrate deep into the Earth, allowing scientists to study the subsurface structure and composition. This information is crucial for a variety of applications, including oil and gas exploration, mining, and even underground carbon storage. As the truck moves along, it leaves behind a trail of vibrations that can be detected by specialized equipment. These vibrations are like a map, revealing the secrets of the subsurface and helping scientists better understand the Earth's hidden structures. Seismic vessels are used for geo-analysis of the oil reserves in the sea. Like seismic trucks, these are equipped with cutting-edge technologies, including seismic sources, receivers, and recording systems. Best practices also include the safety of marine life before seismic operations. Safety precautions are taken to ensure no damage. Moreover, they intensify waves gradually so sound-sensitive marine animals can leave the area. The vessel generally has a compressed air gun. It fires compressed air at regular intervals. The compressed air, in the form of waves, hits the seafloor and creates a sound that penetrates deep into the subsurface rock at the bottom of the ocean. As a reaction, sound waves bounce back to the vessel. These returning waves are detected, analyzed, and recorded. With analysis of the seismic data, scientists can gain valuable insights into the formation of rocks, oceanic trenches, and other geological features that shape our planet. Generally, a 3D map is generated from the received data. It helps them find the most efficient and safest drilling location. Once a promising site is identified, the next step is drilling. Oil companies contract with specialized drilling firms and pay for labor and rig day rates. Drilling depths, rock hardness, weather conditions, and distance from the site all impact the drilling duration. The drilling process involves creating a wellbore. A wellbore is a hole drilled into the earth to access the oil reservoir. The drilling site is chosen based on geological surveys and seismic data to identify potential oil reservoirs. After that, the land is leveled and cleared of debris to ensure a stable surface for the drilling rig. Now, it is time to set up a drilling rig. Firstly, the platform's floor is installed precisely at the point from where the drilling bit will bore the hole. Then, a power and pump station are installed side by side of the main platform. Next, the tower is assembled and erected. This tower functions as a hoisting system. It hoists the drilling bit and its components. Lastly, a drilling bit is set up to drill holes in the earth. A turntable on the floor rotates the drilling bit. Generally, this part keeps rotating the drill bit at 45 to 50 rotations per minute. A special-sided pipe made of steel engages with the turntable to rotate the drilling bit connected via several pipes. Moreover, an additional weight is placed over the rotating pipe so the bit can bore effectively. These pipes are known as drilling strings. As the bit penetrates deeper into the ground, more pipes are attached to extend its reach. It is a pretty laborious task. For this reason, some companies have designed automated rig systems capable of extending the drilling string on their own. With drilling, special fluids are injected to circulate through the drill string. A mud engineer monitors and controls the concentration of the mud. This fluid circulation not only removes the cutting or remnants of bored material, but it also cools down the drilling equipment. More casings follow the bit as it drills, strengthening the borehole. At different stages, cement is introduced through the casings to cover gaps between the pipe and the surrounding rock, ensuring its permanence, safety, and security. Drilling straight down to the well is comparatively easy, but most oil reservoirs beneath the earth are in the form of unconnected oil pockets. These are called shales. To extract oil from shales, horizontal drilling is done. At depth, the well is turned horizontally and extended thousands of feet to the reservoir. The drilling bit approaches one shale after another. Then blasts are charged to puncture the reservoir. Next, water, sand, and a small percentage of additives are injected into the punched holes at very high pressure. This results in tiny microfractures throughout the rock. Sand is displaced in these small fractures and helps hold them open so oil, gas, and water can flow from the impermeable rock. In 2012, the US had 45,000 horizontal wells operational. Offshore drilling is not so much different than onshore drilling, but it poses its own unique challenges. For instance, drilling work is handled from a floating ship, which is thousands of feet above the drilling point. If the bit does not go according to expectation, it is taken out of the well on the ship, and the drilling process starts again from the beginning.
Right now we were at 20,000 feet. So we had to pull all the way back out from 20,000 feet, and then we got to go all the way back down.
For instance, here we have the Transocean Poseidon, a 781-foot-long drilling ship that can dig 40,000 feet deep. A drilling bit consists of several diamonds capable of cutting the hardest rock formation. Imagine tons of steel pipes on it that can stretch up to 5 miles from the ship to just above the cutting point. In other words, a drilling bit along with a drilling assembly has to sustain the weight of approximately 80 loaded trucks. Moreover, the temperature at the tip of each bit rises to 1500 Fahrenheit while cutting the rock formations. Luckily, this drilling boat has 2 derricks. One prepares the pipe, and the other continues the drilling process. In total, this boat will drill 8 wells 30,000 feet deep in the seabed. After that, they will be interconnected via a network of pipes, and lastly, an oil rig will be towed to connect with the oil well and extract crude oil from the treasure underneath the seabed. An oil rig is a floating platform that serves as a base and pumps out crude oil from the wells. Here is the Vito, the latest oil rig that belongs to the well-known oil and gas company Shell. It has 4 pontoon legs that stand 90 feet deep in the water. They keep the oil rig floating on the surface of the sea. However, a floating rig can't stay in its place, therefore it is anchored using mooring lines. Vito is not floating straight above the well. Instead, it is horizontally 1.5 miles away from where the flow lines are coming to the rig. This distance prevents the pipes from bending in case the floating platform moves forward and backward. Connecting the pipe with the seabed well network and the floating rig is a complicated process. It involves meticulous handling with 0 chance of error. To do this, miles of thick pipes are joined together, and they are spooled up on the giant reel of a ship. Here, the Seven Seas ship is ready to lay the pipe on the seabed. It floated to the spot above the wellhead. Then, a ROV dives into the water. It connects the pipe hanging from the ship to a pre-installed anchor on the seabed. Then, the ship releases a pipe to lay the pipe on the seafloor. The angle between the ship and the pipe being laid plays a critical role. For this purpose, the ship's rear tower is raised and lowered as needed. If the angle is too inclined, the pipe will buckle and distort permanently. If the angle is too obtuse, the ship will destabilize. To connect the flow lines with the oil rig, a remotely operated vehicle is used. It hangs the flow lines to the boat winch, standing at a distance from the oil rig. Next, the flow line is pulled up on the surface. When the flow line reaches close to the surface of the water, it is slowly moved toward the oil rig to transfer the load from the boat to the rig. Here, the 300 tons of steel pipes are dangling in the water. In such scenarios, there is no room for mistakes. Next, the ROV carefully takes the flow line head to one side of the pontoon. There, it is locked, which puts smiles on the team. Once the drilling is complete, the drill pipes are removed and the well is completed by installing a casing and cementing it in place. It prevents the well from collapsing and ensures the oil and gas flow freely. From the oil well, a sucker rod pumping unit extracts the oil. It is the most recognized piece of surface equipment used in the extraction of oil. People call it by different names such as horsehead pump, donkey pump, thirsty bird, and even dinosaur pump. However, it is widely known as pump jack. A high-speed electric motor runs the pump jack through a gear reducer attached to the rotating system. The rotating system features a counterweight connected via a crank to the gear reducer. A pit arm also joins it with the walking beam. This counterweight counterbalances the weight of the sucker rods and the fluid being pumped. The sucker rod has a head at its end, which is often called a horsehead. The horsehead moves up and down, pumping crude oil via a rod string. The upper part of the rod string, which can be seen from the surface, is called the polished rod. It moves through a stuffing box that prevents leakage while pumping. It also directs the oil to the link assembly. After drilling, the oil is extracted from the reservoir. This is the production phase, where the oil is brought to the surface through a process called primary production. The oil and gas are extracted from the well using pumps and other equipment. The primary component involved in pumping out crude oil from the well is the sucker rod pumping unit. This unit consists of a sucker rod, a plunger, and a pumping jack. The sucker rod is connected to the plunger, which moves up and down inside the well bore, creating suction and pressure to extract oil from the well. Down in the earth, there is a downhole pump. It contains a plunger with a traveling valve and a standing valve. When the plunger goes down the pump chamber, the moving valve is open, but the standing valve is closed. When the plunger travels back up, the traveling valves close. The standing valve remains open, sucking in additional fluid from the reservoir. In this way, the pump continuously pumps out the crude oil. Now, we have crude oil, but it is still crude. It requires refining through a refinery that will transform it into the standard petrol we use in our vehicles and other petroleum products. But first, the crude oil needs to be transported. From the onshore well, it can be pumped straight to a refinery through pipes. From offshore, tanker ships transport the oil. Globally, 60% of the oil is transported via these floating oil tankers. Take a look at the Universal Leader. This oil carrier ship is 1,502 feet long and can carry over 4,000 tons of oil. At the refinery, the crude oil is processed to separate the various components. This involves heating the oil to separate the different hydrocarbons, such as gasoline, diesel, and jet fuel. The refining process is complex and involves multiple stages, including distillation, cracking, and reforming. The first step in refining crude oil is distillation. This process involves heating the crude oil to around 350 centigrade and turning it into a mixture of gases. These gases are then piped into a tall cylinder called a fractional tower. The gases rise up inside the tower, passing through a series of horizontal trays and baffles called bubble caps. The temperature at each tray is controlled to match the boiling point of a particular hydrocarbon. Different hydrocarbons condense off of the gas cloud at varying temperatures, generating distinct fractions. The fractions produced in the distillation process are then further refined through cracking and reforming. Cracking involves breaking down the heavier fractions into lighter, higher-value products. This process is used to produce gasoline and jet fuel from heavy gas oils. Reforming, on the other hand, involves inducing chemical reactions under pressure to change the composition of the hydrocarbon chain. This process is typically used on lower-value light fractions to produce more gasoline. The final steps involve combining the various streams from the processing units to create the desired petroleum products. The octane level, vapor pressure ratings, and other special considerations determine the gasoline blend. The final products are then stored temporarily in large tanks on a tank farm near the refinery before being transported to locations across the country. From refineries, the final products go to storage facilities and gas stations for consumption. In this network of oil distribution, oil tankers play a crucial role. They distribute the ready-to-use fuel to oil and gas stations every day. But a fully filled oil truck on city roads is like moving with a bomb through residential areas. Something like that happened in Pakistan in 2017 when a fire engulfed 138 people. Next to its borders, the situation is not so different. According to reports, 168,000 Indians lost their lives in road accidents in 2022. Shell started a program, Hum Rahi, for its employee drivers to improve such a dire situation. Many lives can be saved by analyzing the traffic patterns, ensuring the driver's health and improving their comfort. The refined products are then transported to storage facilities and, eventually, to consumers. It includes a network of pipelines, rail cars, and tanker trucks. This transportation process is critical since it ensures that the products reach their destinations safely and efficiently. However, the Air Forces have found a new way to supply fuel to their jet planes and aircraft. For years, Orbit Fab, a US-based company, has been trying to build a network of gas stations in space. If it succeeds, would you like to travel in space? Let us know in the comments below. Do like, share, and subscribe, and we will see you next time.